To subtract mixed numbers, it's really important to know the difference between a mixed number and an improper fraction. Now at the moment, if you look at question 1, we've got 2 1/3 subtract 1 1/2. Both of these are mixed numbers because there's a whole number, which is the 2 and the 1 in 2 1/3 and 1 1/2, and there's a fraction. However, an improper fraction is one where it's just a fraction where the top number, or the numerator, is bigger than the denominator. So our first step in subtracting mixed numbers is to turn all of these mixed numbers into improper fractions. So in our methods side over here, I'm going to write turn mixed numbers into improper fractions. So in order to do that, you have to look at the whole number. So in this case, we've got ourselves a 2. Now, you can look at the denominator, which is 3, and go, okay, how many thirds make 2 wholes? Well, in this case, in all cases, you know that 3 thirds make a whole, so 6 thirds would make 2 wholes, and then we've got 1 left over. So that means that 2 1/3 is the same as saying 7 thirds. We then look at our 1 1/2, which is next to it, and we think how many halves make a whole? Well, 2 halves make a whole, and then we've got 1 left over, which makes 3 halves. So now we've rewritten our fraction problem here in improper fractions. Now, just like in previous videos where we've done addition and subtraction of just fractions, not mixed numbers, it's really important to then find the common denominator. So I'll add that to the method side over here on the right. Now, just as a little recap, in order to find the common denominator, we look at our denominators, which are our 3 and our 2, and we write out those times tables if you're not sure. So let's write out the 3. So we've got 3, 6, 9, 12, and we write out the 2 times tables, 2, 4, 6, 8. Now we look at those and we think, okay, are either of these the same? Which, yes, we've got the 6, which is the same, and that's our lowest number, which means that that's our common denominator. So then we rewrite our problem with that 6 as being our denominator. So now we look at our denominators. So in the first one, it's 3. And we think, what did we do to that 3 to get it into a 6? Well, we multiplied it by 2. Whatever you do to that denominator, you must also do to the numerator, because we're trying to find the equivalent fraction of 7 thirds where the denominator is 6. So we're multiplying that 7 by 2 as well to make 14. Then we do exactly the same with the 3 halves. We go, what did we do to that 2 to turn it into a 6? Well, we've multiplied it by 3. So we must do exactly the same to our numerator. So we'll multiply that by 3 as well, which leaves us with 9/6. So now our problem is 14/6 take away 9/6. So just like this is now a normal fraction problem, you just subtract the numerators. So I'll add that to our method side on the right hand side here. So you subtract your numerators, so 14 take away 9 is 5, and the denominator stays the same, which is 6. So our answer to this first question is 5/6. Now I'd like you to look at number 2, and we're going to follow the method on the right hand side step by step. So it says here, number 1, turn mixed numbers into improper fractions. Now these numbers are going to be a little bit higher, but it's still the same method. So you think, how many quarters are in a whole? Well, 4 quarters are in one whole. So that means how many quarters are in 4 wholes? 16 quarters are in 4 wholes, and there's 1 left over, which means we've got 17 quarters here. Now we look at the 2 2/3, and you think, how many thirds are in a whole? Well, 3 thirds are in a whole. So how many thirds are in 2 wholes? 6 thirds. And then you've got 2 left over, which means you add that on to make 8 thirds. Now, we have to rewrite our, we need to find our common denominator. So I'm going to write out some times tables again. So my 4s go 4, 8, 12, 16. Our 3s, 3, 6, 9, 12. And we look to see which is the lowest number that's in both of those. And in this case, it's 12. So we know that the denominator we're looking for in both of these is 12. Now we go back to that same method that we did in the first, where it says that we're trying to find the equivalent of 17 over 4 in twelfths. So we look at the 4 and we go, okay, we multiply that by 3. So then we must multiply 17 by 3. Now, that's quite a tricky sum. So we're not expecting anyone to immediately be able to do that in their head. Some of you will, some of you won't. So you can always write it out in a bit of a column like this. So let's just remind ourselves how to do this. Well, you multiply the ones or the units first. So 7 times by 3 makes 21. Carry your 2. 3 times by 1 is 3, plus your 2 that you've carried, which makes 5. So now we've got 51 twelfths. Then we look at our 8 over 3 and we think, what do we do to 3 to get it into 12? Well, we multiply it by 4. So we must do the same to our numerator. So it's 8 multiplied by 4 as well. And this one you should really know because it's just your times table. So 8 times by 4 is 32. Now, part 3 of the method says you're subtracting your numerators. So if we subtract our numerators, it's 51, take away 32. Again, some of you will be able to do this in your head, some of you might not. So I'll just do a little recap on how to do column subtraction. So we start on our ones or our units. 1 take away 2, you can't do it. So we borrow from the 5, turning it into a 4, and adding that 1 over onto the ones to make it 11. Now it's 11 take away 2, which makes 9, and 4 take away 3, which makes 1. Now that is now our numerator. So our numerator is 19 over 12. Now, that's still an improper fraction, which means that we've got to do an extra step. So in our method here, I'm going to write turn improper fraction back into a mixed number. So it's basically the reverse of what we did at the start when we think, okay, how many twelfths is a whole? Well, 12 twelfths is one whole, which means we've got one whole there. And then you think, what's left over to get up to 19? Well, to get from 12 to 19, there's 7 left over, so that becomes our numerator, and our denominator stays the same. So your answer for this one is 1 7/12.